All right. Well, thank you for that wonderful introduction, Mark. And please, first of all, let me know if you can't see my screen, because I've got the title slide for the deck open. Yeah.
We can see it.
That's
Everything's
fantastic.
looking good.
Beautiful. And I'll just say hello very quickly, because that was a wonderful introduction. And thank you all for joining. And I hope you're having a good summer under the circumstances. I'm going to cut the video for the screen share, and I'll join you again on video at the end. So hit that. And also, to sort of manage expectations a bit here, I've got a good 75 to 80 minutes of content, or so here. So just to manage expectations, I can talk faster, but there's a lot to cover here, and it's really often difficult to have a good session in just 60 minutes, especially if you want to take questions. So
yeah,
by all means,
I think we're okay if you go a little longer.
Yeah,
no problem.
Sure.
No problem at all.
Just keep your eye on that chat window, and don't hesitate for a moment to interrupt me at any point with any kind of questions that folks are throwing out. And with that, I'll just jump right in. And this is an introduction to Azure Cosmos DB. I don't know how many of you were at my session last month where we talked about data modeling. If you were, then you got a bit of a leg up on this session. If you weren't, I'm making no assumptions about any previous knowledge of Cosmos DB. So certainly going to cover everything from the ground up. But if you did attend the session last month, then I think you'll find some of the core concepts a bit familiar, hopefully. All right. So with that, I'm going to jump right in. I'm going to skip who I'm about. Other than to say that I've got a course on Pluralsight that covers all of this stuff, and I refresh it once a year, and it's due for another one, and it'll be refreshed. It was refreshed in 2019, and it's going to be refreshed again in next month. And so you can definitely check that out, because it's a good 6 hours of content right there. All right, so here's a link that actually does work for a change. Usually I have to ask you to wait a day. I have a chance to upload it, but I got this uploaded in advance of tonight's session. So just go ahead and hit sfdp_cosmos_intro, and you will hit my OneDrive and then be able to download a zip file with this deck and tons of code. This is an introduction, so it's a mix of visual demos in the slides, a couple of live demos, and just a lot of overview coverage. So I'm break it down into 4 parts. The overview, we'll talk about throughput and cost, we'll talk about horizontal partition, we'll talk about global distribution. Now, those 3, the throughput, partitioning, and global distribution, those are core concepts in Cosmos DB. But we're going to spend a lot of time in the overview section talking about everything else. So there's going to be the overview is going to be quite a bit of a grab bag that sets the stage as broadly as I can in the amount of time that we have. So some folks are still not clear on what the term NoSQL is, even though it's been used for a long time and thrown around for a long time. If you haven't actually worked in that space, you still might not be clear on what it is. It's certainly not what it sounds like, right? It has nothing to do with SQL as a language. In fact, in Cosmos DB, we use some variant of SQL to actually query, and the most common way of working with Cosmos DB is with something known as the SQL API. So it's certainly not what it sounds like. It's really just a buzzword for solving the problem of big data, often defined by the 3 V's: volume, velocity, and variety, well beyond the bounds of relational database systems and the architectures that relational database systems are designed for, which are essentially scale-up architectures, right? Back in the day, you just got a bigger box with a faster CPU and more RAM and bigger disk, and that's how you scaled until you hit the ceiling on that, and we have. And at some point, you can't build a bigger machine, and then the only thing you can do to scale out is to scale out instead of up. That is to add more machines. So distribute the workload not just on 1 machine, but 2, 3, 4, 10, 100, 1,000 if necessary. Just keep adding machines, and therefore, and thereby, in a sense, scale infinitely. Okay, and in terms of volume, we're talking about storage capacity. In terms of velocity, we're talking about throughput and servicing a request. And in terms of variety, we're talking about different shapes and sizes of data. And that's in a nutshell what NoSQL is. And at least that's my definition of it over the years. So having defined that term, we can now like look at what a NoSQL database is, like in general, not just Cosmos DB. So any NoSQL database out there is going to be distributed from the ground up. Like replication is not an afterthought or an added feature. It's at the core of the system that there are multiple replicas of your data always, and that will ensure, well, you know, a number of things. High availability, certainly. If one replica goes down, you continue to operate because you have other replicas, and you can replace the failed one without bringing your applications down. And of course, you know, the more replicas you have, the more requests you can service at a time, right? Because you have more replicas that can serve up requests, reads, that is. And it's definitely built for scale out. So from the ground up, a NoSQL database is designed to just work across a farm of machines, a cluster of machines, a set of servers, in order to give you elastic scale in not just in terms of storage, but also throughput. And then there's the idea of schema-free, right? Where you know, you have data in all different shapes and sizes, and the difficulties of coping with an enforced schema, like you have in the relational world, the SQL Server, or a defined shape, where you have, you know, or you have data types and constraints, and you know, the data has to fit this shape, and if you need to change that shape, you have to, you know, the alter table add column or change a data type or anything like that can be extremely painful to do if you need continuous uptime, especially for globally distributed apps. Like globally distributing schema changes is an extremely painful thing to do in general. Right, so you know, those are the kind of design goals. So what's Cosmos DB? Well, it is a massively scalable NoSQL database, fully managed on Azure, platform as a service, with service level agreements to 5 nines, as they like to boast. 99.9999% SLAs, if I said that right, on not just availability, but consistency and throughput. So what does that mean in practice? Well, actually, on availability, you actually only get 4 nines unless you globally distribute, then you get 5 nines. And at least in terms of availability, the math comes to you're guaranteed you'll never have more than 5.26 minutes of downtime in a year, right? Like you just have those guarantees. And you have super fast reads and writes. If I think we saw that in our last session, and you'll see that, you know, the reads and writes are in the single-digit milliseconds, under 10 milliseconds in most cases. You get automatic horizontal partitioning. In the early days, you had to do a lot of this work yourself, but today Cosmos DB will automatically add partitions, as we'll talk about. And that will give you elastic scale because each partition will add storage and CPU power. And from the ground up, it's globally distributed. It is designed to be globally distributed with simple point-and-click geo-replication, including multi-master, which allows multiple write regions and conflict resolution and all that stuff that goes with it. And we'll have a demo on that. And it's not just a JSON document database, although going outside the scope of the JSON document database, you know, it's not in scope for this session. We'll have one slide that talks a little bit more about these multiple models, but it's not exclusively necessarily a JSON document database. It also supports these other models, table, graph, and columnar, and in particular, graph. You know, it could warrant an entire session unto itself on the graph capabilities in Cosmos DB. And we're going to be focusing mostly on the JSON document database, but you know, you do have those other options. It's very easy to get started. There's a 30-day free trial known as Try Cosmos. You do need a Microsoft account. I'm guessing everyone here has one, and it's really simple to just start using Cosmos DB, and it's free, and they just blow your data away every 30 days. There's no limit to how many times you can sign up again, and you know, basically keep playing with it without paying anything. Of course, the typical way is through the Azure portal, where you, of course, do need an Azure subscription. And pretty recently, I don't know, maybe about 3 or 4 months ago, a free tier was announced, where roughly it comes about the first $24 a month free, as long as you don't exceed 5 gigabytes of storage or 400 request units per second, and I'll explain what that means soon enough. As long as you don't exceed that throughput and that storage, you can actually use Cosmos DB for production workloads that are, small to medium sized production workloads and not pay anything. There's also a local emulator that, given the, it's been around for a long time, the local emulator, but given the free tier and the 30-day free trial, it's, I guess, less compelling to have it, except if you need to work without an internet connection, I suppose. Okay. All right, so let's just jump right in with a visual demo of how you get started creating a Cosmos DB account. Just, I'll pause for a moment to catch my breath and get a swig of water, and you can also check to see if there's any questions yet in the chat, Mark.
Yeah, I've been checking. There are no questions yet. Just encouragement to, if you need to go a little long, go ahead.
Fantastic. Okay, great. So let's just jump right in and create our first Cosmos DB account. These are pretty fresh screens that I've recorded, so we don't have to, wait for the actual provisioning of hardware. I'm going to call out the steps here. You go ahead and click and create a resource like you would for any new Azure resource. There you go and pick Azure Cosmos DB. Like any Azure resource that you're creating, you would have to pick a subscription and then a new or existing resource group in that subscription. So I'll choose Cosmos Demos RG for resource group. And then you need to come up with a globally unique name for your account, some name that no one else has picked. Excuse me. And if I choose Lenni Demo, if you see the green check mark on the right, that's an indication that it's available. And I'll just go on and pick the API in this dropdown. So what does that mean exactly? I already alluded that this it's multi-model, multi-API. What does that mean? It means that you can choose the core API, which is also known as the SQL API, which is the default, or you can choose any of these alternatives, MongoDB, Cassandra, Table, or as I said, Gremlin, which gives you a graph data model. And we'll talk more about it as I promised, but I'll just say at this point that in most cases for greenfield applications, unless you have a compelling reason, which we can talk about later, you would go with the core API or the SQL API. So we'll stick with that. Now there's notebooks, which you definitely want to enable, and it's in preview now. And actually, it's going to be in preview for a while, but it's got nothing to do with not being feature complete because they are feature complete. It's simply that they haven't been geo-replicated to all regions. And for various reasons that I can't really get into, it may be a while till they are available in all regions. And so that's why they're in preview. But otherwise, they are feature ready. You do want to use them. If you notice, the location is set to West US beneath. But when I enable notebooks, it gets cleared. See, when it's off, it's West US. But when I change it to on, that gets cleared. And that's just because notebooks aren't available in West US. Which is fine because I'm in New York, so it's East US. Although, there's another West US data center called West US 2 where notebooks are available. Anyway, this is a very kind of bogus, if I can use that word, setting that they added recently, which I don't like. It doesn't really, has no effect on the service. It just has an effect on the front end, on the portal's UI. If you choose production, then the UI experience is such that many of the defaults are appropriate for production environments, as opposed to if you leave it set to non-production, then they're not. So I'll move to production when I'm ready. I'll leave the default set to non-production. It's a little silly that the geo-redundancy here looks disabled because geo-redundancy is certainly not disabled for the account. That means global distribution. It's only disabled because if you look at the tooltip, every Azure region has a buddy, has a pair, is paired with another one. And if since I chose East US, its natural buddy in Azure is West US, and notebooks aren't available in West US. So I can't enable geo-redundancy between those two regions because I've enabled notebooks. And if this sounds, convoluted, believe me, the team is aware of it and they're going to clean up this experience. But certainly we will be able to enable global distribution, and you're going to see a demo on that. Multi-region rights is below that. That's again, is multi-master, the ability to write to any region and have those rights geo-replicate to everywhere else. And availability zones are a feature that it's not a Cosmos DB feature. It's a feature in Azure that gives added redundancy within a region. Particularly useful cases where, some countries don't actually allow you sharing with data outside with other regions. And if you want, that added redundancy in case of a failure within one region, availability zones can help with that. But that's all I'm going to say about availability zones. The truth is that once you've picked your location, you've set everything you need to create a new Cosmos DB account. I'm just going through some of the other interesting options that are available as well. So we'll go ahead and click Review and Create, and sometimes it takes more, sometimes it takes less. It's estimating 11 minutes here. Of course, we won't have to wait because this is pre-recorded. But I've seen it take as long as 15. I've seen it take as little as 6. Depends on capacity and demand and whatnot, and what region you've chosen. Then you go ahead and click on Create, and if all goes well, and it all usually does go well, you will be able to click Go to Resource, and you will have created your first Cosmos DB account. It starts you off in the Quick Start page, which I find to be useless. Let's go to the Overview page, and there on the Overview page, you can see clearly that at least at this stage, we have one region. It's one read and write region in East US. I click on the Keys blade. There you can find the URI, which is essentially the endpoint. If you see, does this thing work? Oh yeah. So you can see there's my account name, which is essentially what the endpoint is, and then the primary and master key, primary and secondary master key. And then the connection strings, which is nothing more than a concatenation of that URI and the primary key in the case of the primary connection string and the secondary key in the case of the secondary connection string. Sometimes, depending on the SDK that you're working with, sometimes you'll be asked for a single connection string and one parameter to supply. Sometimes you'll be asked for 2 separate parameters, which are the URI and the master key. And the reason they have primaries and secondaries, if you're familiar with the concept of key rotation, right? It enables you to keep your applications up and running even as you rotate these keys or change their values. You can just switch to this, because it takes a bit of time to change one of the keys, and you don't want any downtime. So you start with the primary key, right? And all your applications are configured to use the primary key, or the primary connection string, if you will. And then when you feel that's been compromised, or you just want to change it because for whatever reason it's part of your security practice, you rotate them on a routine schedule, then you would reconfigure all of your applications to start using the secondary key, which you've never used before and has never been divulged, never been used. And your applications continue to run while you then rotate the primary, which takes a bit of time, a few minutes. And once that's done, you reconfigure the applications to using the new primary and rotate the secondary. And that's why you have 2. Click on the Data Explorer. See, we have no data yet. We have a bunch of notebooks, and there's even more now. Not going to be able to talk much about notebooks. I think if you were at my last session, you saw me using some Python notebooks, little snippets of code that are very convenient to run right up here in the portal against your data. And what's quite interesting as well is that C# is supported now as well. All right, so we have an account. And now the first thing we want to do is create a container. Data gets stored in a container inside of a database. So you need a container for your data. It's like well, I was about to say like a table, but I'll retract that statement. And so I'll go ahead and click on New Container. The blade opens up. I want to create a new or existing database. Well, I'm starting scratch, so I don't have an existing database. It'll be a new database. I'll call it Families. I'm going to store documents about families. This will be super simple, only one type of document. And you'll notice that there's a default here that's very unfortunate, because you almost always want to uncheck that checkbox, provisioning database throughput. So we'll talk more about throughput, and there's auto scale versus manual, but we'll talk about that separately as well. So there's manual throughput here in a range of 400 to what looks like to be 1 million, although theoretically there's no upper limit. And you normally want to provision this at the container level. So the hierarchy is like a database is made up of multiple containers, almost loosely like in a relational database. One database is made up of multiple tables, right? So but in Cosmos DB, you would want to provision throughput on each individual container, and with this checkbox check, that's not going to happen. The throughput that you provision here will get distributed across all the containers, usually not what you want. So when I uncheck it, and I've just unchecked it, you'll notice that down here, the throughput has dropped to the container level. The same input that we had, auto-scaler manual in the same range, has dropped to the container level, right? Okay, so next I'm going to name the container, and again, super simple. I'm going to call it families as well. And look at the partition key. Now I have to decide the most important, I have to make the most important decision, not in my life, but in the lifetime of this container, let's say, because you can't change it once it's set for the lifetime of the container. And this is how Cosmos DB is going to distribute the workload of your data based on the pattern of data, the distribution of unique values in the property that you specify here. And it's actually suggesting that it can be hierarchical. So let's go with that. Let's say we'll have a hierarchical document with a zip code nested beneath address. Let's go with that. And we'll talk more about throughput, but we'll go with the lowest value possible, which is 400. And you see pricing there. So, simply put, lower numbers are going to cost, less on your Azure bill and give you lower performance, and higher numbers are going to give you higher performance at a higher cost, essentially. And we'll talk more about how that works. Click OK. And now there's our families database with our families container inside of it. And there's the items I could click on. It looks like, this looks very familiar. Stored procedures, user-defined functions, and triggers. I'm not going to be able to talk much about them other than to say, at least in this session, at least to say that they work nothing like the way you think, or at least they work nothing like the way they work in SQL Server. But they are essentially server-side code written actually in JavaScript. I'll talk briefly about the significance of choosing a partition key when it comes to using stored procedures, but other than that, we won't really talk much about stored procedures. And then the very next step after we would have created a container would be, well, obviously we want to put some documents in that container. Then you'll be building applications that ingest data, possibly at very high volume and velocity, like if it's IoT telemetry. Excuse me. Or you'll be migrating data using Azure Data Factory or other migration techniques. But we're going to use the simplest way. Simplest technique is to just hand type JSON in the portal. Click on items. We've got no items yet, obviously. I'll click on new item, and here I can actually hand type JSON. And it is proposing a JSON document with an ID property. So I need to supply an ID. And actually, if I don't supply one, a GUID will get assigned. So there needs to be an ID, and if I don't supply one, then a GUID will get assigned. But we also know that that zip code property that's necessarily beneath the address, we need one of those too, because that's our partition key. So I'll hand type this document, and there you can see there is the zip code right there nested beneath the address. So that's the partition key right there. When I click, and I'm not supplying an ID. There's no ID here. I'll just click save, and bingo, there's the partition key. That should say address zip code, but it's too tight. The ID is a GUID, like I said, it got assigned automatically. This other stuff that got assigned, we don't have to worry about for now, at least. There's a timestamp, that's an epoch value, that's a date time value right there. The other properties here are really not that important. Let's start with an underscore. There's the ID, and there's the zip code, which is the partition key. And two things should become kind of stand out in terms of a very stark difference between this kind of a database and a SQL Server or any relational database. First of all, did I define a schema? No, I just dumped data in, right? That's quite a huge difference. In other words, I could drop another document in that's slightly different, and it'll be fine, and it's all good, and everything's indexed and queryable. That's first of all, and second of all, I have arrays here, and I've just made them simple strings. 2 items in this array and 3 items in this array. But of course, these could be full-blown objects. This could be an array of 3 objects, which would normally be modeled as separate rows in separate tables in the relational world in a one-to-many relationship that we would join when they're retrieving data, and we would have to, separate the updates out to 2 separate tables when user saves changes. But here, everything's kind of like pre-joined, if you will. which is wonderful because there's no concept of joins. Cosmos DB doesn't support joins. So if you pre-join your one-to-few relationships, you know, it's a very different approach to the way you model data in relational databases. I talked about these additional properties. I'll go ahead, yeah, I'll create another document that this time has a pets property. Like there was no, we didn't have a pets we didn't need a pets property before. We need a pets property now. It's no problem. There's no alter table, add column. There's no schema change issues. And of course, you know, all of the mayhem and chaos that can result from this, you know, kind of Wild West way of doing things where there are no rules. Obviously, you know, you have new concerns about, you know, how do you present a unified view of data where the schema changes and varies. And that's why, you know, it's always good practice to have a type property to be clear about what type of document you're looking at, and a version property so you can kind of reliably determine what you know, the structure of a document without taking, you know, brittle assumptions at the, you know, the shape of a document. You know. So there you can see that the second document is actually in a different partition because it has a different zip code. And that means that these two documents live in two separate logical partitions behind the scenes, which we'll talk about more soon. Our last demo, we'll do some querying. Right? So we'll just select all documents where address.city equals Chicago. It looks like ordinary SQL, but that dot annotation right there is doing a drill down. Of course, that is returning both documents, and that is a cross-partition query because each document is in a different zip code. But it returns them both. If I zero in on one zip code and then it's a single partition query, I get just that one. Here, I'm looking for all properties, or all documents that have that pets property. Now, it's just returning the one in 60603, but this is still a cross-partition query because it is checking all zip codes, obviously. And so this is a cross-partition query that is only returning documents where there's a pets property. So if there's a pets property and it's null, that doesn't qualify it. Because it's still a defined property, right? Okay, yeah. So assuming that there's a property called kids, because there may or may not be, right? And assuming if there is a kids property that it's an array, because it may or may not be, then array length will return the number of elements in that array. And so this will return all the documents that have more than 2 kids, and there you have it. Those are my 3 kids right there, Adam, Jacqueline, and Josh. All right, let's just pull back from the demos and talk quickly about management options that you have. Well, we saw the portal. Portal is chock full of ways to manage your Cosmos DB account. There's also the Azure CLI. If you're not familiar already with it, you just kind of click this little icon up here and you get a shell, and you can, you know, script things out like a bash shell here. Here I'm actually going to create a database. And I'll set some variables like with my resource group name and the account name and the name of my database, and bingo, I have a new database. Same thing if you're a PowerShell person, then you have these commandlets that, you know, do the same thing. Here I've got some PowerShell variables, and I've created a new database in PowerShell. Notebooks, you know, don't have the time tonight to show you, maybe another time, but they're very awesome. You just have some markdown, which could be HTML with images and text and whatnot, and you can have code cells. And here again, I'm doing something very basic. There's a Cosmos client that's built into the Python SDK. It's built right into every notebook. And, you know, here I'm creating a database, and there it's been created. Everything boils down to the REST API at the end of the day. So anything you can do in Cosmos DB is possible through the REST API. You normally don't want to get your hands dirty with that. Here's how you would like issue a post, because setting up the headers is not that simple. The request headers, I mean. But you know, that's why we have SDKs, right? That's why we have the .NET SDK and the Python SDK and the Java SDK, all these, you know, depending on your development platform, and they abstract away the REST API. Cosmos DB automatically indexes everything, which is very different than, you know, we're used to being very skillful at how we index our SQL Server tables. You know, you don't want to over-index, you don't want to under-index, you want to index just right, and the composite index, and this kind of index, and so on. And it's like a total art form, right? But that just doesn't exist in this world. We have a concept known as inverted indexing. There's no schema, right? You just store a document like this, And as soon as you dump that into a container, it gets parsed into this tree structure where all those leaf nodes, all the data elements wind up as leaf nodes. And you'll notice that the arrays themselves, like here and here, they just wind up being another level in the hierarchy. So everything kind of just boils down to this tree, which then gets flattened and indexed, essentially. So you wind up having a container that has no schema, but yet it's fully indexed. So when you run a query like this, it's able to consume that index and immediately zone in on the path to the property that you're looking for and find the document. Now, you can tune this for performance, and if you have very big documents and you don't need them indexed because you're always doing point reads or you're only querying on one or two properties, you can lower the cost of your writes and improve the performance of your writes by defining a custom indexing policy. And some of you might recall that from our last session that we looked at the change feed. So every container has a built-in change feed. As you insert or update documents into the container, it gets emitted to the change feed. And that opens up a whole world of possibilities for event-driven microservices, which I would hope to do a session on next time I'm back. Got a full session on that. It's really quite advanced, but quite fun, and it's advanced, but definitely approachable. And certainly if with a background in this session, it's definitely easy enough to follow along and look at all of these kind of interesting possibilities for larger architectures, broader architectures. We're nearing the end of our overview. Believe it or not, this is still all that introduction and overview. We talked about multiple APIs and data models. So we saw that drop down, right? There's a SQL API, which gives you JSON documents, like the ones we've been looking at. The MongoDB API gives you BSON documents, but which is very similar to JSON. If you ever worked with MongoDB, BSON essentially is JSON. It's a binary encoded version of JSON, but it's essentially JSON. But the MongoDB API is the differences are much bigger than JSON versus BSON. The MongoDB API is essentially MongoDB compatibility layer. It's an emulation mode. It is designed to attract MongoDB people. But it is a layer of abstraction over the core API, which is the SQL API. You would have no reason to go with the MongoDB API unless you were, let's say, migrating an existing MongoDB application to use Cosmos as the backend. And then you don't want to modify any code, just change your connection string. Or otherwise want to invest, otherwise want to leverage in your investment in MongoDB, but still embrace Cosmos DB as a backend. There's the table API, which emulates Azure Table Storage. Nothing interesting there. It's just an emulation layer if you have an investment in Azure Table Storage. The Gremlin API is so far the only really interesting alternative to the SQL API because it gives you a graph data model, which we could have a session on unto itself. That makes it very easy to traverse interconnected relationships between vertices and edges, as they're called, which just fancy names for entities and relationships, respectively. And Cassandra is similar to MongoDB. If you're a Cassandra person, you can use this API to treat Cosmos DB as though it were Cassandra from the perspective of a client application, but still under the covers, it's Cosmos DB. So it's up to you. How do you want to treat your data? Like a document, like a key value, like a graph, like Cassandra columnar. Cosmos DB doesn't care because all of the fundamental concepts of global distribution, horizontal partitioning, automatic indexing, provision throughput, all of these core concepts, they are durable concepts that kind of transcend whichever API or data model you choose to work with. And under the covers, it's all stored as ARS, which is just a common kind of key value store. So that might make you think that you should have interoperability between these APIs since they're all stored in the same format, but actually because of impedance mismatch, you actually can't. I'm not going to get into that because I'm running low on time. I'm just going to jump into throughput and cost, but I will pause here because that's a kind of a logical place to pause to see if there's any questions queued up.
Yeah, so at the moment, there are no questions
Great.
that have been posted.
Perfect.
But if anybody wants to raise them either verbally or via chat, this is a
Sure.
good time to do it.
Right. So jumping into
Nobody has dropped off the call, just so you know.
oh,
Every
great.
single attendee is still here.
Oh, well, I'm glad you're still all with me and trying to keep the pace going and keep you engaged.
Okay.
How do we measure, so now we're talking about throughput and costs, right? So this is about performance. And when we talk about performance, there's two ways that we can measure performance. Very often it's in terms of latency or throughput. So in latency is really the perceived performance. It's the total wait time. The analogy I like to use is from the time I sit down and place my order to the waiter till the time the food arrives, right? Whereas throughput is the perspective of the server, and getting back to the food example, how many burgers can this kitchen serve up before they have to hire more chefs or more kitchen equipment, right? Right. It has nothing to do with how long or short the waiter has to walk back and forth between your table and the kitchen. So, you can reduce latency by getting the seat closer to the kitchen, right? But it's not going to affect how many burgers that kitchen is capable of producing within a given amount of time before they have to hire more chefs. So it's really important to distinguish latency and throughput when you're measuring performance. And we're going to focus on throughput for now. And I mentioned RU's request units, and these are a fundamental concept in Cosmos DB. And this is the number you're always trying to keep down. You're always trying to keep the RU charges for your queries low and as low as possible, because the RUs are essentially throughput currency. I mean, literally currency that they translate into your Azure bill. So it's just this kind of rolled up measure of memory, CPU, and IOPS. It's similar to DTUs in SQL Azure or Azure SQL Database. And that way you don't have to be concerned with those hardware metrics, and you just think about this consistent thing called RU. And now all requests are certainly not equal. Reads are always going to be cheaper than writes. Writes have to update multiple replicas. Writes have to update indexes. They're always going to cost more. You can make them cost less by tweaking your indexing policy perhaps, but they're always going to cost more than reads. And reads as like a direct read, like a point read where the ID of a document, and just that one document is always going to be faster than a SQL query with a where clause that has to parse and evaluate it. And then more complex SQL queries are obviously going to cost more than less complex. Was I muted?
I'm not sure what the issue was. I
All right.
was looking for messages, chat,
okay.
and I don't know what happened. I lost you. Sorry about that.
No worries. I don't know how far back that was, but
no, it was 10 seconds.
Oh, that's fine.
Not far.
The good news is that even though all requests aren't equal, they're all the same request is always going to cost the same number of request units. So the request units themselves are deterministic, and Cosmos DB is very transparent about the RU charges. Like it says here, every response header is going to show you the RU is going to show you what the RU charge was, and in the portal when we ran those queries, if you click on query stats, you can see this query here costs 2.83 RUs. This query, well, looks more complex. We've got functions, array length, and starts with, so sure, it's going to cost a little more.
You don't have your screen.
Oh. Huh.
Yeah, maybe just try to share your screen again. We can hear you, but
yeah.
Okay, there you go. Okay, awesome.
So this is the slide I was just describing without the screen share, showing that this simpler query here costs 2.83 RUs. This one, which has some functions in it, and obviously is a bit of a more complex where clause, well, it's going to cost a few more RUs. But if the data doesn't change in the container, this same query is always going to cost the same number of RUs. You got these metrics here in the portal where you can see your requests. You can see your throttled requests, which means errors, essentially, because you exceeded your provision throughput. And we'll talk about what that means in a moment. Programmatically, when you issue a create state to create a new document, here I'm using the .NET SDK to dynamic up an anonymous object. Looks like JSON, but it's not. It's a C# dynamic type. And I am writing it to the container, and it's telling me the cost is 9.9 RUs. So here's stuff that's new and exciting, because there's 3 ways that you can provision throughput. There are 3 kind of throughput offers. The first is manual, and that's been around since the beginning, where you reserve a fixed number of request units per second that are always guaranteed to be available. You can raise or lower it as you need it, but you have to raise and lower it. It's suitable when your highs and lows are predictable, like seasonal type of workloads where it's when it's busy season, when you've done a promotion, when you can expect your highs and lows. So if you are just hovering under 5,000 RUs a second, then that's what you'll provision. You won't want to go over that. Again, of course, it's unlikely that you'll always be at 5,000 RUs a second. When you can predict, all right, you're going to want to lower it, because if you don't lower it when you don't need it, that amounts to unused capacity that you're still paying for. So when you know that you don't need those 5,000, you'll lower it to 2,500, and you'll raise it back up to 5,000 when you need to. But again, that's all assuming that it is a predictable workload, and many workloads are. But if you have unpredictable workloads, then you might want to be interested in auto-scale. Now, auto-scale costs more, quite a bit more, 1.5 times as much. We'll get to the pricing in a moment. But it still guarantees, it still guarantees provision throughput is always going to be available. And it maintains the guarantee on the service level agreements for a throughput and availability and consistency and single-digit millisecond reads and writes. So all you need to do is know your max. You just don't need to know the highs and lows. If you know you don't need more than 5,000, then that's what you set. And Cosmos DB will automatically scale the throughput up and down on an hourly basis. It will reevaluate. If it spikes up, it'll jump up and it won't throw the exception. And then if an hour later it can go down, it'll go down. But it'll never go down to less than 10% of what you set as the max. So if you set 5,000, it'll be within the range of 500 to 5,000. Sorry, too fast there. All right. And then there's the third offer rather, which is so new that it's not even out there yet. It's not even in preview yet. So this is brand new and expect it soon. But I'm very pleased with it. It's serverless. It's perfect. It's consumption model. You don't provision throughput. You just pay for the RUs that you use. This is great for small applications, maybe that you might be sharing with families and friends. Cosmos DB doesn't have to be for humongous workloads. It could just be a demo that you give from time to time. So you have, mostly idle. Now you can use autoscale for that, but it's like I said. First of all, it's costs 1.5 times as much as manual. And second of all, most of the time you're idle and you're still always paying for that 10%, even at the low points. And like I said, it adjusts at hourly intervals. So if you just have a spike for a few seconds here or a minute there, you've still got unused capacity that is wasted dollars. So with serverless, it works the way you would think, right? When each request, how many RUs? That's the cost. You don't get the guarantees on performance because the hardware is not necessarily provisioned. You might have cold starts, but it's a wonderful option. I'm going to, in the interest of time, skip ahead to the pricing slide and jump into partitioning. And I definitely want to show the global distribution demo as well before we end. So storage, I think is cheap. What do I know? But a quarter per gig seems cheap, right? And really, you're paying. The pricing is divided between storage and throughput, but it's typically mostly throughput, right? So there's manual provision throughput. How many request units per second are guaranteed to be available to your application? every second. You know how much the operations cost. I whizzed through a bunch of slides in the interest of time, so you didn't get to see. There's a capacity calculator where you could, there are tools to help you estimate how big are your documents, how many reads per second do you need, how many writes per second do you need. You plug in those variables, you get a sense, okay, of how many request units per second you need to provision, and you're paying per hour, but you're guaranteed that they're available per second. So you're going to pay 0.008 cents per hour for every 100 request units per second per region, but we're not globally distributed yet. So, and the minimum is 400. So if you do the math, it comes to about $24 a month, 400 RUs a second. Okay. Auto scale, like I said, it costs 1.5 times as much. So the average, if you provision between 400 and 4, if you set the maximum at 4,000, and therefore the range is 400 to 4,000, these are not exact figures like these are, but there is some measure by which you can save with auto scale, but really it depends on the predictability of your throughput. And, I'm not going to get into a marketing spiel, but I do think it's a hefty price to pay for auto scale. Serverless is, I think, very cheap. A quarter per million RUs. You can consume 5 million RUs in a month and only pay $1.25. So I'm really excited about the serverless offering coming, and there are more options, and there's a link to learn more. So horizontal partitioning is a super important concept of massive scale out within a container. We store data in a container, but behind the container, there are these physical partitions. And they scale out automatically, meaning Cosmos DB will split the partition just to make your container grow. So you just have the one container, but behind the container, there's a cluster of physical partitions, and they just get added and added and added. And each one's got its own disk and CPU. So effectively, you get unlimited storage and unlimited throughput. So drilling in a little bit more, any document can land on any physical partition. So we want to concern ourselves more with the logical partitions, because how does Cosmos DB know which physical partition to use? The answer is it depends on the logical partition, and that's what we are in control of with that partition key. Like if you go with the username property in a social networking example, it would mean all of Tim's documents are in one logical partition, and Andrew's are in his, and so on. And yet each logical partition can have documents of different types. So in each logical partition, you can have one document for the user, a bunch of documents for that user's posts, and a bunch more for that user's comments, maybe a bunch more for that user's likes. So they're all different types. The only thing they have in common is that one partition key that groups them together. Maximum document size is 2 megabytes. Maximum logical partition size is 20 gigabytes. You got to keep these things in mind when you're modeling your data. Partition splits are the beauty of Cosmos DB, because as you write documents to a container, based on the partition key, it'll be grouped with other documents in the same logical partition as indicated by the bounded blue lines. We've determined the partition key, so we determine the documents that are being grouped in those blue lines, but which physical partition each group or each logical partition lands on, that's none of our concern. And at some point, when a partition gets too busy, by too busy, it doesn't have to necessarily mean that the disk is getting full. It could also be throughput demand. Cosmos DB will simply split, literally add a new partition and literally move half the logical partitions over from that one physical partition without disturbing the others. And then, things just keep going and going and so on and so on. So that's really the beauty of Cosmos DB. All that happens automatically. But you don't want, logical partitions like this. Obviously, from a storage perspective, that's going to create what's called a hot partition. You want more evenly distributed storage like this. But even if it's evenly distributed, you have to be careful about your access patterns in terms of throughput. So if you choose a creation date, well, wouldn't that mean that all the writes of the day are going to the same logical partition? Yeah, not a good idea. It creates another hot partition. So if you provision 3,000 RUs, when you provision RUs on a container, those RUs are divided evenly by the number of physical partitions that happen to be in that container at a given time. So if I provision and therefore pay for, let's say 30,000 RUs for my container, in this example, there are 3 physical partitions. Each physical partition is getting 10,000 RUs. And I'm only using the physical partition in the middle. I'm paying for 30,000, I'm only getting 10. essentially. So you want to avoid the situations like that. You want, like, again, if you go with the username, that'll be a nice distribution. Users will be distributed both in terms of storage and throughput. I'm going to jump ahead because in the interest of time, I really want to show you the global distribution and then end on that. So I'll pause one more time for questions, and I would estimate that in 15 minutes or so, it'll be a wrap.
Okay, I don't see any additional questions
Beautiful.
posted yet.
All right. So global distribution. This is pretty cool stuff as well. Why do we replicate? There are several reasons. Of course, we know the more replicas you have, the more availability you have. If one goes down, you have more resilience, you have more availability. And if you distribute it across multiple regions, well, then you're bringing it closer to the consumer, right? And then there's obvious business continuity reasons. A replica fails within a region, there are other replicas to take over, and if there should be an unfortunate event of an entire region going down, then by distributing data globally, you are protected as well. So these are all the regions as of February 2020. Some are still announced, but there are so many and they're always expanding. It's really simple to do this. You just click and point on this map. Here I've got an account distributed across 5 regions. You just point and click. It's really easy to associate and disassociate regions, if you will. Excuse me. And if you enable multi-master, then every region can be written to as well at super low latency. I'm very eager to show the demo, so I'm kind of going to rush a little bit through these slides. But there you can see that I've got one right, East US is my right region, and West Europe is, and West US and West Europe are additional read regions. But if I enable multi-master, all 3 are pretty much equal. I mean, there's no longer a concept of one of them being the primary. They're all equal. All right, let's have our demo and call it a night. An actual live demo. Hopefully you can all still see my screen. And what I've got here is a Cosmos DB account called CDB Global. If I click on it, and let me just make sure if I click on it, you can see that it's located, actually, it's set for West US and Southeast Asia already, but it was originally set up in West US. And I've also got 2 virtual machines, CDB WUS, which is also located in West US, and CDB SEA, which is located in Southeast Asia. Now, I really didn't mean to spill the beans and show you that I had already enabled global distribution between those 2 regions. Because in fact, my application is only configured at this time to recognize West US. So it's as if I hadn't yet thrown the switch to enable replication across to Southeast Asia, because doing that would take about 10 minutes, and we don't want to wait those 10 minutes. So just imagine that it's only set, read and write locations are only set for West US. But I've also got these 2 VMs, and these VMs are representing applications that are running in those regions. Southeast Asia, because we have customers in Southeast Asia, and they're connecting to, well, I'm using a VM because it's easiest to demo it that way, but it would be a web application, a web API, maybe a microservice, an Azure function, any kind of application code that is accessing Cosmos DB. Now, this one's in West US, the same region as the data. This one's in Southeast Asia, continents away. So, but they're both running the identical program, identical code, both, right? With some very simple methods to test queries, reads, and writes, and conflicts as well, which will be the kind of finale of the demo. It's the exact same code in both regions. And if you look at the configuration in app settings JSON, you can see they're both pointing to the same, they both have identical configuration. They're both pointing to the same endpoint, which again, at the moment, is the data is only available in West US, and the same master key. So it's really identical. I'll go ahead and give it a run here in West US. I'll do some queries. I'll do 100 of them. And boy, that's pretty fast. I'll do another 100. Yeah, Look at the latency. Single-digit milliseconds. I mean, actually, in most cases, under 5 milliseconds. There's one that went to 8. Occasionally, you'll see one that might even exceed, yeah, okay, occasion. But in almost all cases, under 5 milliseconds. So 100 queries in under half a second. And the cost, always the same, 2.83 RUs, which is about the cheapest query you can have. This is a simple, it's the same document that I'm querying over and over. Let's try direct reads. Wow, those are even faster. Those are even faster. And the cost, only 1 RU. So if you know the partition key and the ID of a document, a point read will always be fastest. Let's go ahead and over to Southeast Asia. Query. 100. Not looking so good. This is live before your eyes, folks. This is, I mean, it's definitely going back and forth between continents faster than you or I could, but it's taking an eternity compared to the experience in West US. It's taking hundreds of milliseconds to, it's like the waiter, having to walk all that extra distance while the kitchen is still costing 2.83 RUs once you get to the kitchen and issue that request for that document. That query costs 2.83 RUs, no matter how long the waiter has to walk, right? So you can really see a clear distinction between latency and throughput here. And reads, well, they are, latency is marginally better. Well, I mean, not even measurable, because it's still taking the same amount of time. RUs, of course, are down. RU charges, of course, down to 1 RU. But let's go back over to taking too long for me to wait. I'll just start that early. Let's test writes. Do 100 writes. What I'm doing is I'm taking that same document and I'm replacing it 100 times, each time appending the last name Jones with a different GUID. Okay, now let's just do 10 reads here. I know, because we know it's really slow. Just do 10 reads here. And you'll notice that in Southeast Asia, look at the GUID. It starts with 6D, which matches the last write out of West US. So that's good, right? Obviously, but writes here. I'm just going to do 10 in Southeast Asia here on the right. Let's do 10 because you know how slow they are. All right. So they're pretty slow. And oh, I'm sorry. I meant to do read. Because I still want to prove that the last write out of Southeast Asia with a GUID beginning with 03 isn't being read in West US. But clearly, clearly the experience is not very good in Southeast Asia. Now, I've already kind of I spilled the beans earlier. I had already enabled global distribution. The truth is that the cost for these writes should be half of that. The RU charge that you're seeing there is because it is actually already being written out to 2 regions. The reason that it still seems so bad in Southeast Asia is because after enabling geo-replication, I have to make one minor configuration change to my application to make it work automatically with, to pick the preferred region. And then Cosmos DB will automatically use that region and fail over automatically to the next nearest available region if that region is not available. Now, I only have 2 in this demo, so there's only 1 possible failover. But if you had more than 2, it would, by geo-proximity, know which is the closest one to fail over to automatically. So if I go back to the portal, again, like I said, I had already gone to replicate data globally. You can see that it's already set for West US and Southeast Asia. I've already enabled multi-master writes. That takes about, it could take 10 or 12 minutes per region. So once you've done that, all you have to do is go to your application. In the interest of time, since everything's good in West US, I'm just going to make the change here in Southeast Asia. All of the tests that we are running, I've been calling this method get client right here. which have been retrieving that endpoint and master key from app settings JSON, all we need to do is add a preferred region. We'll also pull from app settings JSON. And, sorry, no, my bad. Trying to go from memory. I need to create a new Cosmos client options. A new Cosmos client options. And in those options, set the application region to be my preferred region, which I will pull from app settings JSON. And then take these options and plug them in. Oops, that semicolon doesn't belong there. And plug them in to the Cosmos client constructor. Now, you want the bits in all regions to be identical, right? So now you have identical bits in both regions. But in app settings JSON in West US, I'm going to set my Cosmos region to be West. And all we need to do over in Southeast Asia is set that to Southeast Asia. In the interest of time, I'm not going to run into West US again because Perf was perfect there to begin with. But here in Southeast Asia, oh, I think I was still running. The application was still running. Hang on one second. Here we are in Southeast Asia. Yeah. Sorry. Excuse me. Read 100 times. There you go. And this is Southeast Asia. If you don't believe me, there. It's move. How do you move this over? There you go. SEA, CDB SEA. Read. Write. I'm going to do write. I'm going to do a write from Southeast Asia 100 times. Super fast. It's writing to Southeast Asia, but it's immediately being geo-replicated over to West US. Same issue. I'm gonna now read in West US, and I am reading that 7.3 document, the last document written out of Southeast Asia. So I'm getting super fast queries, reads, and writes in all regions. I have one more demo, but it's not critical. I want to gauge the audience. If we want to call it quits now, we can. If not, I do have a multi-user conflict resolution demo that takes about 5 or 6 minutes. But no.
Yeah, so there is a question from Nandan. Couldn't it do auto routing like with a CDN?
You mean the way a CDN works? Mm-hmm. Well, to my knowledge, this is kind of a homing logic that's baked into the SDKs. So I don't really know much about how the homing works, how the automatic failover works. I just know that with the SDK, you just need to set the preferred region to be the region, to match the same region that the application instance is running in. And if that region is not available, the SDK finds the nearest available region by geo-proximity.
Okay.
How? I don't know.
Okay, we've only had 2 people drop off, so I assume everybody's still interested. If you go for
it's only best. Yeah, sure, let's do it. So obviously, let's do it. Obviously, multi-master is wonderful because you have low latency reads and writes no matter what region you're in, but it gives us something that we don't want, and and that is potentially conflicts. So you invite conflicts, obviously. What happens if the user in Southeast Asia and the user in West US update the same document at the same time before Cosmos DB gets the chance to replicate that change, right? That's going to be a conflict. And there are three options for dealing with this. One is last writer wins. That's the default. So remember that TS property that I mentioned, that timestamp property. The higher the number, the later of timestamp it is. So here is last writer wins is set, and you can see two documents. They have the same ID and the same partition key, and therefore they are the same document. But this user set the address to 456 Harbor, and this user set it to 789, and so it's a conflict. This timestamp is higher than this timestamp. With this policy, this document gets written, the document on the left gets thrown away. Or you can write a custom procedure, like a stored procedure. One important thing I didn't mention about stored procedures earlier, which I said I would, is when you pick a partition key, it's also a boundary for updates, transactional updates inside of a stored procedure. Stored procedures are a very nice feature in Cosmos DB where you can write code that runs on the Cosmos DB side and can update multiple documents transactionally, so that if they all either will commit or roll back, they'll never have something partial. And that's only possible with documents within the same logical partition. So it's another important consideration for picking a partition key. But in this case here, you can say that when there's a conflict, send the conflicting documents to my stored procedure, and my stored procedure will decide the winner. Maybe my stored procedure will merge the changes and decide, a final version of the document that's based on, pieces of both, whatever. It's your stored procedure. And you just pick merge procedure and name your stored procedure. The third option, which is what I'm about to demo, is to resolve your conflicts offline later, right? These first two happen in real time. When there's a conflict, either the last writer will win or a stored procedure will determine the winner. Or you can just push them into the conflicts feed. A winner is still going to be chosen, but it's could be somewhat arbitrary. It's based on a quorum majority and whatnot, and there's going to be a winner, and whoever doesn't win gets written to the change feed, conflicts feed. So what I actually have in Southeast Asia and in West US is, let me see if I'm actually still running. I am. And sorry. This one as well. This one is not running. All right, so I'm going to hit conflict here, and I'm going to hit conflict here. And what's actually all that's happening, oops. You see here, this guy's waiting 31 seconds. This guy's waiting 25 seconds. Because the clocks are synchronized. So at the top of the minute, they're both going to wake up. And at the same time, they're going to try to update this Jones document. Each time, they're going to put the machine name in to the document. So we'll see who gets to win. By now, it should only be a few more seconds before the top of the minute. There we go. You can see they're both fired off at the exact same time. So who won? So each update, I incremented the number, and there's the machine name West US or Southeast Asia. Let's go back on over to the portal and look at our Data Explorer. And there, because multi-master is enabled, there's a conflicts feed. You wouldn't be here otherwise. And here they are. You can consume this programmatically as well. So West US 1, actually, if you just look at the one document in the container, West US 1, and this was the 100th update, obviously, but West US 1, the 100th update. But if you look in the conflicts feed, you can see all of the failures. All of the ones that failed from Southeast Asia are here. So I could actually I could actually click update. I can click delete to just clean out the conflicts feed, say, okay, I don't need to keep that. Or I can click update and recover the failed document, or I can actually manually change it before I click update. So, hopefully I didn't go on for too long. I'm not exactly sure when we started, but I think it was about an hour and 15 minutes ago. So there's always more to cover. I'd love to be back and show you some more good stuff, but especially with change feed and microservices. But until then, for now, I'll pass it back on to you, Mark.